Okay, folks, it's 11:01. Prof. Ben Daniel, if you're ready, we can begin.
Yeah, thank you, Prof. Yeah, I'm ready.
Okay, great. Colleagues, welcome to our institutional research webinar series. I'm your host today, Rabi Dunpat, the Director of Teaching and Learning at UKZN. And it gives me great pleasure to welcome a distinguished guest all the way from south of New Zealand, the South Island, Professor Ben Daniel, who is a professor in higher education and the head of Department of Higher Education Development. That's at the University of Otago in New Zealand. As a matter of interest, Otago University was founded in 1869 and is New Zealand's first and oldest university. So we are privileged to have you represent Otago, Ben. So Ben obtained his PhD in educational technology and artificial intelligence in education from the University of Saskatchewan in Canada. He is now at Otago. He now leads academic development programs in research methodology, quantitative and qualitative and mixed methods research, as well as educational technology, and he supervises postgraduate students in these areas. His research focuses on investigation of big data and data analytics in higher education. He is also a keen researcher in the pedagogy of research methods. He has published over 160 peer-reviewed articles, including 5 books in artificial intelligence in education. His recent book, Daniel and Heartland, 2018, focuses on higher education research methodology, which is a step-by-step guide to the research process. Loiso will put this up in the chat. So this book provides early career academics and postgraduate students with an overview of methods and strategies for researching higher education. Ben has received several best paper and poster awards in top international conferences. His research has been translated into Korean, Chinese, Portuguese, and Arabic. And in 2020, he received 2 visiting professor appointments with the University of Makerere University and the University of Technology in Malaysia. Daniel will speak to us today on the theme, Key Big Data Opportunities for End Users in Higher Education. So Ben, welcome to South Africa. Ben is no stranger to UKZN. He has visited in the past and will continue to do so under our invitation in the future. Ben, you have the session is 90 minutes in total. Please feel free to utilize that time as you deem comfortable, allowing sufficient time for discussion and debate and contribution by members. And we have approximately 40 participants in the session today. So colleagues, I invite you to enjoy the presentation, but please also jot down your comments and contributions in preparation for the Q&A session at the end. Thank you. Over to you, Daniel, Prof. Daniel.
Thank you, Prof. Robbie Danforth, and for that kind welcome and introduction. And also I'd like to take this opportunity to thank Lucio Machiko for reaching out and organizing the event. All right, so I will try my best to cover as much as possible within the time, and as well as give an opportunity for you to ask questions or to make comments. So maybe the best to start this is to share my screen. All right, so the focus today is really to explore the potentials and the challenges of utilizing big data broadly in higher education, and in particularly focusing on end users, or the three main end users. So I thought what I start with this presentation is really to give to you a quick overview of where I am currently. I should say that I'm originally from South Sudan. I also hold Canadian citizenship. And about 8 years ago, I decided to move down south here to New Zealand, where I'm currently working. So for those of you who might not know New Zealand is a small country, essentially comprises of two islands, the north and the south. And where we are, we essentially in the extreme southern part of New Zealand. We always joke that we don't have any neighbor other than the ocean and Antarctica. So New Zealand is pretty much an island as well as a continent in its own right, with a lot of features that you normally see in countries within a continent. And the University of Otago is located in the city of Dunedin. And Dunedin is one of the biggest cities in the north, in the South Island. And if you look at the map here, that's roughly the map of Dunedin city. And then of course, Dunedin, you can see it's on the extreme part of the southern island here. So while New Zealand in general is known for its outdoor activities, so people who are highly active tend to enjoy it quite a lot. Except of course in the south, we are a place where you get all kinds of activities as well as strange weather patterns. But essentially it's an outdoor or a country where there'll be a lot of interesting outdoor activities. As Prof. Rabi indicated, New Zealand, Otago is one of the oldest universities in New Zealand, founded in 1869. And it has main campus in Dunedin and other campuses in some of the biggest cities of New Zealand. So we have Christchurch, for instance, Wellington, and those campuses are predominantly campus of medicine and other related health sciences. And then we also have a small campus in Vicago, which is another small town in the South Island. And that campus is mainly hosting or housing education. And then of course, part of my department, which is the Higher Education Development Center. So the university has been embarking on a lot of new activities, if you like, in terms of rearranging learning spaces. So the library is one of those places that is no longer only a place for reading books, but also a place for all kinds of social interactions that are related to either formal or informal learning environments. So the university has been essentially reorganizing the space to optimize some of those social activities that can contribute to one way or another to student learning. And as you can see behind the picture there, or the picture of those individuals there, there's the clock tower, and the clock tower is where the senior management of the university offices are located. And as you can you can see that clock tower is always a symbol of power. So that's where most of the vice chancellor, the deputy vice chancellor, and all the senior academic staff, that's where the offices are. Right, so I am located in the Department of Higher Education, and as you'll appreciate that the higher education is pretty much a new discipline. It's a new discipline in the sense that it brings together different individuals or the individuals from different disciplines. So it's highly multidisciplinary, an emerging area of inquiry. So what we do in higher education, we really essentially trying to study the structural and functional aspects of universities and other forms of tertiary systems or tertiary institutions, whether it's something to do with how those institutions are governed, or whether it's something to do with learning and teaching, or research, or any other policy related aspects that surrounding higher education. So that's essentially an area that perhaps became more more interesting in the 90s, and suddenly it's growing. So there are a lot of academics who are actively researching into this area. Now, this is just a quick, this is just a quick overview of the individuals that are working in the department. So as I said, we're not only multidisciplinary, but we're also, I think, drawn from different nationalities. So from this picture, you can see that we have people from China, we have people from UK, we have people from New Zealand, of course, we have people from Brazil, we have people from Canada, we have people from Nigeria, we have people from Japan, Singapore, Malaysia, and Israel. So we're pretty much a collection of people all around the world. And that's not only typical of our department, but essentially, I think about 70% of the faculty at our universities come from outside New Zealand. So it's a highly diverse, multicultural and multinational. And I should also mention actually that there's also South African there in the department. So who we are as a department, we're established in 1978, perhaps one of the oldest department in the world. And we're kind of set up differently in the sense that we operate as a service to the university, but also we operate as a traditional academic department where we have our own programs. We have postgraduate certificates in higher education. We have diploma in higher education, postgraduate diploma in higher education. We have masters in higher education, and we have a cohort of PhD students who are studying different aspects of higher education. So those are our students, as well as different credit-bearing programs. So that makes us slightly unique from some of the setup that are available in the world, where it might be either maybe 70 or 80% or maybe 100% fully serviced. We do have credit-bearing programs in our department. So maybe what I thought I would do as getting into the topic of today is to give you a quick overview of the different research communities that are surrounding educational technology. And again, this is my own history, so it might not be as accurate as comprehensive as it should be, but this should give you an overview of where this thing called big data and learning analytics are coming from. And I should just make a comment that educational technology research communities tend to emerge around new technologies. And this is not to say that those communities are not necessarily coming up with new technologies or new innovation in teaching and learning, but essentially whenever it is a new technology that has become dominant, a handful or a large part of that would constitute a community of inquiry or research community. If you look at the internet, for instance, the internet has been around for many, many years, essentially developed as a military project, or what they call Department of Advanced Research Network, or DARPAT, which is an American project started in the 60s as a way to prepare for any possible attack from Russia, because that was the Cold War times. So the internet became available. And of course, there were some rich opportunities for using the internet for teaching. So, and then came a research community known as computer-based instruction. So a number of people start exploring possibilities of using the internet to deliver content to students. So there's been a huge interest there, with a lot of progress as such. And perhaps not until the 1989, I should say, when Sir Bernard Lee of CERN labs in Switzerland developed the first web browser, or what is known now the World Wide Web. And of course, that's what sometimes referred to as Web 1.0. That was when people can now utilize all those computer-based instruction and build in some kind of intelligence. Intelligence in the sense that the system can not only deliver content, but also learn about the users, learn about the students, learn about some of the deficiencies or the struggle that the students might have, and provide some direction or some kind of tutoring. So you get a research community around what they call intelligent tutoring systems. And this community is very active up to today. They have conferences and they have all kinds of academic activities. So the ITS, or Intelligent Tutoring Systems, essentially was built around the idea that if you want to build an intelligent educational system, and then you have to have at least 3 modules. The first module is the module that deliver content, or the pedagogical module. And then you have another module, which is the tutor. And this tutoring module plays the role of a teacher. And then the other module is really the student module. So the student module will be holding information about the student, about who they are, what their browsing patterns or their navigational patterns. And then the pedagogical module and the tutor module will use that information to adapt any learning as appropriate to individual based, of course, on their learning needs. And I should say that there's pretty much crossover of individuals from those communities. So when we get to a point of Web 2.0, which is really the social media, and that's perhaps happened rapidly, and particularly within the year 2000, where the like of Google became really an efficient search engine, and you have YouTube, and you have all those different media or forms of technologies that are no longer requiring any particular programming skills. So unlike Web 1.0, where actually if you wanted to create a web page, you have to learn hyper markup text language, or HTML, JavaScript, and Java, and all that to put some interactivity. With Web 2.0, you can essentially type and create web pages without necessarily knowing the technical skills that are required to do that. So there are platforms that you can utilize. And so that has changed the paradigm of learning. That has created a sense of community online. So what that means is that people can now contribute content. Instead of waiting for someone to create the content for them, they can contribute content. They can upload their own videos. As we see today, we can upload our own videos and make our own documentary and all those things. So that's really revolutionary. And so within that emerged an area which is a branch of intelligent tutoring system, but then covers much more than that, what we call artificial intelligence in education. And again, that is another community that is highly active. What happens then is that the AI ed, or the artificial intelligence in education community, brings together the computer scientists, bring together the education people, brings together the sociologists, the anthropologists, and indeed anyone who is interested in understanding or studying or supporting learning together, and harnessing the knowledge from the multidisciplinary areas and bringing that together to create more intelligent, more adaptive, and more engaging learning environments. So again, that community is quite active up to today. Around 2008, there was a bit of interest in collection of data, because we now have lots of technologies that essentially can create a lot of data. So people are interested in looking at what they can learn from the various data that people generate online, and whether that data could be used to develop more adaptive, more tailor-made, more personalized learning systems and learning environment. And that's the community of educational data mining. The community of educational data mining, again, the individuals that also actively engage in artificial intelligence in education, as well as intelligent tutoring systems. So if you go to some of those conferences, you pretty much see the same individuals in both conferences. Now, it is perhaps at that point where there was an interest in the utilization of big data and learning analytics in education. This is not to say that big data and learning analytics actually started in education, but then because individuals who are working in data, educational data mining, use a lot of statistical methods and algorithms and techniques that are really looking at patterns of engagement in learning environments. And then when the big data paradigm became kind of well known, individuals and then started thinking, oh, okay, maybe we need to apply some of those techniques and the paradigm itself to see whether we can learn something that can help us understand what is going on within educational systems. So that's really where the big data and learning analytics research community start forming. And again, if you look at that community, you can see that there are individuals who are also very active in different kinds of AI ed issues. There are also individuals that are researching the role of big data and analytics in higher education. So that gives you a quick overview of where this research community is coming from. And essentially from there, and then some of the research projects, and certainly some of the research projects that I'm engaging, really utilizing what we call educational data science. And that's really an approach that look at automated systems, algorithms, quantify self, qualify self, and all that in order to understand learning issues or issues in education. Now, this is just an overview of what educational data science is, or indeed what data science is. There are a lot of data science programs in many universities now, and they might be set up differently. But what is core here is that data science programs always have to have some statistical programs in them, computer science, mathematics, and all other disciplines such as bioinformatics, health informatics, medical informatics, and in fact, of course, a heavy presence of data mining and different kinds of research methodologies that are used to understand various kinds of problems. And of course, core to that is artificial intelligence, which is perhaps comes in the form of machine learning, whether it's supervised or unsupervised machine learning. Right, another history here again. I hope you don't think that I'm a historian at the end of this, but the idea of using data in higher education is neither new nor original, really. I mean, it started a long time back. If you look at in the 90s or perhaps even before that, universities use a lot of data, and mostly for reporting purposes. Whether it's really record keeping of students who are admitted and students who graduated, students who employed, and all that kind of thing. So it's really something that universities or higher education institutions kept for their own administrative purposes. And then around probably late 90s and early 2000, where there has been a movement around the world where universities are less funded. So governments start spending less on universities, and universities were pressured to justify to different stakeholders that they do exist and they add value. And one way to do that is, of course, to collect data and present all kinds of reports to different stakeholders, whether it's a government or it is an industry, whether it's any kind of form of community or regional government. I wanted to know, what is it that I'm paying for? Show me what you have achieved. So there's been a lot of technologies that were developed then to kind of hold this data, to collect the data, harvest this data, and process those data, and produce or have instant reports that universities can use to satisfy the needs of different stakeholders. And of course, as technology matures, universities start acquiring or buying a lot of enterprise systems, if you like, databases. And those databases now hold a huge amount of information that universities can process in a very short time and use the reports for any purpose that they wanted to. And so as years go on, again, development in database systems, we start looking at, or universities start looking at data warehousing. And in fact, that's where most universities are. even some of the universities that are kind of moving towards big data. A lot of universities have a lot of data warehouses, whether they are really semi-automated or they're completely automated. And so these data warehousing are mainly used for performance, to look at institutional performance, for audit purposes, for forecasting, whether it's forecasting financially in terms of how many students do we need to recruit in order to generate such revenue, and so on and so forth, or whether it's something for compliance that the government might require universities to have. So again, you get a lot of techniques from business intelligence and tools and processes that universities now can use to harvest, process, and generate all kinds of reports. Now, within the data warehousing, most of the work there is really looking at administrative purposes. And then when 2000, let's say around 2012, 2015, when the idea of big data and analytics became prevalent within researchers in higher education, the interest also included the aspect of looking at learning and teaching and research. So KPIs, or key performance indicators around those areas. Can we look at, for instance, data that are generated or students generate in learning management systems to understand the quality or the kinds of learning that is happening? Can we look at the data that is held in our research databases to pull out particular aspects that might be of interest and all that? So there's been a bit of work now looking at building models that can explain what is going on currently, models that can bring together different aspects of learning and teaching in terms of association, and models that essentially can predict and can do some kind of forecast in terms of what will happen in 5 years if we continue the way we do. Are we going to be in trouble in terms of our students? If you're not attracting enough students, or if you're doing the same thing, are we able to attract more students in the future? So those became some of the shift, if you like, in terms of the use of data in higher education. So there's a bit of history there, that the use of data is not really new, but it's something that has changed over the years, changes mostly brought by technology, but also changes that are initiated by the environment. And as I mentioned, that universities are becoming more like corporations. They have to demonstrate certain accountability and be able to show to their stakeholders that indeed they're continuing to add value to society. So, what is the big changes, perhaps, in the interest in big data and educational research? We know that, of course, as I mentioned, changes in technologies, and also there's been changes in data. There's not only data that we manually collect through either surveys or questionnaires, but there are data that people leave data traces whenever they interact with any device. And so the idea is, can we look into those trace data or those computer-generated data and try to understand, can we understand what is going on there? And we also know that the research questions that we need to ask in educational research are no longer the same, because the nature of students have changed. The typical students that come to take degree are no longer, you are 20 years old and all that. So the people returning back from the workforce, for instance, to enroll into a different degree, even if they had some other degrees, and they are moving around micro credentials, where people, engage in a micro learning credit or program in order to understand a particular thing to either enhance their current job or maybe to look for a different job altogether. And as I said, technologies have evolved, so technologies can provide us with data. So we don't have to manually collect data. Technologies can collect data for us. And of course, there are new ways of thinking in terms of educational research. It's no longer the quantitative research, it's no longer the qualitative research, it's no longer the mixed methods research, but we also have to think about quantify self, qualify self, the whole idea around data science. So those are new paradigms that are now very important because they can, provide us with different opportunities of understanding educational problems. The question is, what's big data? Well, there's no such thing called big data, actually. Big data is not a thing, one thing, but big data is a way of thinking. Big data is a paradigm. And there's a bit of debate in the literature where people are saying, well, actually, big data cannot be applied in education because the data in education is not big enough. Well, that's one aspect. Big data refers to data itself, the size of data, but also it refers to other things. It refers to analysis. For instance, Manyika said here is analysis of complex information collected and stored by computers. And that complex information is no longer information that you can fit into your classical legacy database system, but it's something that is now can be stored in the cloud that does not require any limitations in storage. But big data is also a way of thinking. It's a way of thinking in terms of framing research problems. It's a way of verifying data. So it refers not only to volume, but different kinds of data. It also refers to value. Collecting much data does not give you value. It is actually what you do with that data in solving actual problems that can enhance your performance, that can generate revenue, that can give you a competitive advantage. So that's the main aspect of big data. Big data can also refer to veracity. You might be interested in substantiating some facts that you identified from somewhere. So big data allows you to think that way, to verify those facts. And also big data is kind of conceptualized in terms of speed, because today everyone takes selfies and all that. Students are typical consumers of technology. They can navigate between different systems. And so if you're able to harness all those kinds of information that is instantly generated and apply some particular data mining techniques, or you might be able to identify some interesting patterns that in turn you can use those to help you come up with new ways of thinking. So just to give you, I didn't mention that there's a bit of changes in paradigm here. I mean, this is really, again, a simplification of what I meant there, that if you look at like 1900, probably 1700, or even before that, what we used to call the scientific methods, which is the dominant epistemological way of doing science, and that is the quantitative research or the scientific methods. And so not until the 60s, where that way of doing science was no longer enough, we need to be able to understand complex social processes that are embedded within systems in order to have a holistic picture of what is going on. And then you get, of course, your qualitative research tradition there with different methods of thinking, different ways of doing research, different ways of structuring research, and different techniques for collecting data. And then, of course, each and every one of those two traditions or methodologies have their own limitations. And so around 2000 came your mixed methods, which is essentially drawing from the strength of the two in order to provide the researcher with a more holistic and comprehensive view of knowledge. But again, those three traditions were really limited to human oriented way of collecting data. And of course, we have now big data, we have maturity in technology, we have different sophisticated systems collecting data from census to clicks and all that. And so we need a new way of thinking in terms of doing educational research. And therefore, we have the data science, or what we call the fourth tradition. So the fourth tradition is data science itself, which is broadly a discipline that comprises of different techniques for collecting or automating data and processing data, visualizing data, and interpretation of data. So that's where all this is coming from in terms of the utilization of big data in higher education. Now, again, this is just a quick comparison of the traditional educational research and the educational research that is driven by big data or the data science aspect of it. So when you look at traditional educational research, it's highly context dependent, and that context is known only to the researchers. So for instance, you might have a case study where you're studying a particular class of students and all that. But then when you deal with big data, research in big data or educational research in big data, you might not actually know what purpose was the data collected for. So you're really repurposing data. And that comes with a lot of challenges, because it's what we call, what research methodologies call unintended purpose. So it's unintended purpose. The data was collected for something else, and then you are looking at that data to use it for other things. So in the process, the quality of data or the value of that data might diminish. And that's really the second point, where the researcher might use data that is already collected for different purposes. Now, the third point here is that educational research is mainly focused on what we call, or the epistemology or the ontology are clearly known to the researcher. So for instance, a researcher knows why they're engaging in doing quantitative research as opposed to qualitative research, because they might have certain beliefs about the best way of doing science. But when you look at big data, some of those epistemology and ontology actually emerges from the data, emerges in the sense that the more you understand about what is going on, you're more likely to change your values, your views about the knowledge that is in front of you. And the issues around ethics, which is also very important. In educational research, there are clear protocols that we need to follow. But then when you're dealing with big data, some of those problems are actually very hard. And I think ethics review boards all over the world are still coming into terms in terms of addressing some of the complexities, complex issues that are related to doing research using big data. And I'll talk about this. We'll talk about this later on. Things around privacy. How would you know that you're not actually really exposing someone to danger when you publish your work, or when you publish research data that is using big data? So again, we're really dealing with new or we need to know new ways of doing things. So it's no longer only crunching numbers and all that in statistics. We have to look at algorithms and how algorithms perform computation, and how the output of the computation can be visualized in different ways. So it requires a bit of skills there, which essentially in traditional educational research we do not have to worry about. And we talked about the size. In educational research, data is relatively small, whereas in big data, we're probably talking about terabytes or petabytes or exabytes and huge amount of data. We also can be able to crunch numbers in real time and stream data in real time when we're doing educational research. For instance, if you can poke into any data warehouse and know exactly how many students are in how many students are enrolled into the program and predict whether how many of these students are actually going to stay in the program based on certain information that you might collect from students, such as socioeconomic backgrounds and their performance in past papers or past courses. So you can do those things in real time. And the kinds of data that we use also in educational research that employs big data are quite different. We have big systems like Hadoop, Spark, and all those systems that use parallel processing powers in order to crunch or to pull together a huge amount of data and do all those computations. So all those are new tools and new systems that we need to learn as researchers in order to harness the potentials that big data provide us within education. And there's that question, what is analytics? So essentially in the literature, sometimes you get the word analytics and big data used interchangeably, but actually these are two different constructs or things. I mean, analytics is really, again, a multivariate concept, which has to do with how you collect data from, extract data from one system and another, or it might mean different analytical techniques that you use and different ways of presenting computer-generated data in real time or near real time. And the different purposes, of course, of employing analytics. Some of those would be, to identify a problem that you wanted solved immediately. And of course, it requires some use of statistical techniques to process what is happening, or maybe to predict what is more likely to happen. And of course, it uses machine learning algorithms to do that. So that's analytics. Analytics, again, you can have big data without analytics, but then big data without analytics is not going to be useful. So again, big data, as I said, is not really a thing. Big data is a way of thinking. It's a paradigm, if you like, a way of looking at research, a way of looking at data, in a way of trying to make sense of all these multi-dimensional aspects of data that add value to your institution or to the project you're working on. And there are different kinds of different types of analytics and models in education. If you look at the diagram here on the left-hand side, at least in my screen, you get challenges and opportunities. So you have analytics that are intended to do some diagnostics. For instance, why is our student numbers dropping down in the last few years? Is it because our students are going somewhere else? Is the next university taking all of our students? Or is it something to do with our programs? How do we optimize our programs? And then you get to the descriptive analysis, which is really what is going on. And with the descriptive models, they give you some kind of trends, patterns that can help you to start thinking, okay, if I relate A and B, can I be able to understand C? So that's the relational analysis, analytics or models there that give you ability to look at instances that are related, that are more likely to lead to certain outcomes. So in the case of your dropping number of students, if you improve the quality of your teachers, would students come? Would they be attracted because you have some of the best teachers in the country or in the world, right? So you're associating the quality of teaching and then the possibility of attracting students. And you have also all those kind of predictive analytics. So those are the ones that gives you ability to see your performance or to predict the future of your performance, whether it's 5 years or 10 years, however time span that you wanted to put to it. And actionable analytics that look at what economists call actually opportunity cost, where you look at what is the optimal way, what's the optimal, if you employ strategy A versus strategy B, what is optimal there? What are you losing? What are you gaining? So those are actionable analytics. And at the end of the day, of course, you want to develop also some understanding of analytics that provides a complete transformation of the institution. Analytics that help you to optimize your productivity. whether as an institution or as a unit. So those are all different ways of looking at analytics and how different analytics are utilized within education for different purposes or different end goals. Now, who are the users of big data? Well, as you will guess, the immediate users. So for instance, administrators like that information. Again, administrator here could be someone who is a finance person, someone who is HR person, or someone who is an head of department or head of a unit who wanted to improve the program of academic or improve academic programs. It could be someone who wanted to optimize resources, resource allocation. If you're involved in budgeting, how do you optimize that? So again, you can look at financial data, past financial performance and all that, and come up with models that can help you to optimize or to allocate resources. Or it might be something that you wanted to understand what would be the best way to provide support to this particular unit or this administration. And then, of course, you have the students here, which who are also another a group that benefits from analytics. The students can understand how they are doing. They can compare themselves to other students. And teachers can also understand how students are doing. So they can look into students' past performance and capture some of the social demographic elements of students and be able to build some models saying that students who are coming from this particular background or this particular area or this particular age or this particular prior knowledge are more likely to complete this program in such a time as compared to other students. And so more targeted help would be provided to students if you're able to understand the different trajectories that the employer when they're learning in the program. And today we can easily see that through their the navigation pathways in learning management system or other systems that students use either directly to access their courses or for other things. There's a bit of interest in capturing student social media data, which again, I think opens up all kinds of privacy issues there. But certainly I think some people have started talking about that because you can learn a lot about the students themselves and use that information to help them. But also the danger is that information might be used for something else that might not benefit the student in the future. Teachers, teachers can benefit from big data and analytics in that sense, in that I was just looking at I'm looking at the chat here, sorry. Teachers can use information, whether it's from the students to optimize their own teaching, or they can use that information of their own teaching to understand on how they're teaching. Things like, for instance, if they teach in a certain way, a student more likely to be engaged. And how can they improve the way they teach? So teachers can use that information or use big data and analytics to optimize the way they teach. Right. So what we did in Otago, one of the things that we did in this area is what we call University of Otago Technology Enhanced Analytics, or T, research program. And essentially, this is a framework that look at different kinds of analytics within the institution with the hope of building tools and processes that can help institutions share data, either to optimize operations or to support students or to support teachers in terms of teaching. So we have these different forms of analytics. We have institutional analytics. This would be your finances, your HR, and all those data related to administrative or running the university. And then you have your ITS analytics. Those analytics associated with student access, whether it's Wi-Fi deployment in certain areas, or using that information actually to help optimize the service provision of information technology systems within the university. And then we have the academic analytics, which is essentially looking at the nature of programs, degree programs or certificate programs, and enrollment, completion, retentions, and attrition, and all those kind of things. And then, of course, we have the learning analytics, which is to do with how students learn and the different or the various contexts in which the learning happens. So that's what we call the technology enhanced analytics framework within the big data research program. And the idea was really simple. The idea is that, and I think this is quite common in a lot of universities, where universities tend to run disparate systems that hardly talk to each other. So you'll have one department having Excel or their database, stored in Excel, or and others, holding that information in Word documents and all kinds of formats. So it's really hard for someone to link the different systems together to have a more holistic view. But with a framework like what we propose, we're thinking that you could be able to link the administrative data to the research data, to the student data, to the teaching and learning data, and to the curriculum. And if you're able to link that, and perhaps you could be able to do all kinds of processing within the data warehouse. So this is an example of a data warehouse. You have all the records there, and you have this engine, which is the big data analytics schema, which process data and generate a number of reports. And those reports would be either on enrollment and retention, or how good people are doing in terms of teaching, or research productivity in terms of how many, number of articles produced per year, or programs to do with the community. So for instance, the vice chancellor might be interested in, okay, I'm going to present this talk to the stakeholders. Can you generate a report on enrollment for the last 10 years? So that's something that immediately the data warehouse should be able to process and generate, as long as the various databases are connected. And so that was the whole idea, but we've been struggling with trying to bring together disparate information into one place. And so that's just a typical use case scenario that I described. Someone might request some information, and that information can be taken from a database, and then a report can be generated, and that report can be used for all kinds of purposes. Okay, so I think, do we stop here maybe to get some questions, and then I'll just spend a few minutes to finish up?
Ben, I think if it's not much longer to go, perhaps it would be better if you continue. Okay, good. All right, so the last part of this is really some of the projects that we have, individual projects that we have undertaken. So one of the biggest projects that we have used is really to look at research methodology. As I said, research methodology is one of the subjects that I teach. And this is a very complex subject because quite often students that come to take research methods have different prior backgrounds. So it's very, very hard to kind of tailor-make the content to a particular group. So essentially what we then thought of is really to do some kind of research-led approach. And this research-led approach led to understanding different kinds of challenges that we face in teaching methods. Issues around, it's a very complex subject. It sometimes brings numerical and non-numerical students together, and you have to impart those knowledge to them. It is a subject that a lot of students find it difficult to get motivated because they just wanted to understand research methods in order to do
their projects. They're not interested in understanding any other aspect of research methods that might be even useful in the future. Issues around relevant, and I talked about diverse expectations, the way it's being taught, different teachers teach it differently, and so that becomes very complex. So we know that, but then we wanted to find out how we can now use ideas around learning analytics to help us actually solve some of those problems. And so we have this educational data science research approach, which is essentially doing observational research, which is through questionnaires or interviews and all that, but also building a system that that hosts videos and materials that students can access. So the question is, can we learn from the different access patterns from that system or the learning analytics, and combine that with what we know from observational research, and develop some tools. So over the years, we developed tools, and some examples of the tools are what we call TACT, and TACT is an acronym for trustworthiness, auditability, credibility, and transferability. And those are really different strategies for qualitative researchers to apply when they wanted to determine the quality of a qualitative research report. And then we have the tripartite, which is essentially a combination of tools that can help students to carry out a systematic review, but also to be able to present the review in a meaningful way. So that's one example. And I talked about the system. The system essentially is called iMethod. And iMethods will be host the text, videos, and audio, and that tracks students' engagement and visualize those engagement. I'll just go through here. So it gives me a dashboard resources view like this. So for instance, one of the subjects that is frequently viewed is ontology and epistemology. And we know that this is a very difficult philosophical topic. So students quite often go to view that. And what that tells me as a teacher is that perhaps I have to find out a better way of presenting content, a better way of teaching, because students keep going back to that particular module. And also using the same dashboard, I can look at the navigation patterns. And if you look at those balls there, the circles there, the closer they are, the more likely that the content is viewed in the same way, or the level of difficulties or the frequencies in which that content is viewed. So essentially you want them to be very close to each other. But if you have something like here, which is the ontology epistemology, which is very, very far, that tells me that students are really struggling when they access that particular module. And out of that, of course, we developed what we call analytics and research methods, so ARM program, and this became an ongoing program that helps students to understand different kinds of research methods. So it's not only the content, but also tools built around, tools and frameworks built around quantitative, qualitative, and mixed methods. I just want to say that we can share the slides with you later, so that you are able to refer back to those points. And this is just the example of the tripartite model and tool. So again, without going into the details, if you see the first part of the tool here is really coming up with a strategy and a way of, if you like, inclusion and exclusion, criteria for doing a good review. And then the last part here is really how do you go about presenting the outcome of your review. And this is an example of the TAC framework that we talked about. Again, those are the different indicators and then different ways to address those indicators. Someone raised their hand.
We'll take that question during Q&A time then.
Okay. All right. So the other, again, the other way to look at this is really to look at learning analytics as a framework. So in learning analytics, you might be looking at analytics associated with the learners themselves, who they are. you might be interested in analytics associated with the learning activity, how they actually approach, or how do they, how many times do they view content, how many times they click, how long they stay in that page, for instance. And then you have the learning environment as a whole. That could also be another a dimension to look at analytics. And then you have the instructional strategy, which is the way a particular course is taught. So there are different kinds of analytics that you could collect that could help you understand or develop what we call learner models, or models representing the characteristics of the learners. Now, quickly, I'll just give you an overview of some of the current and postgraduate student research projects. Number one here is Hamid completed a couple of years ago, and Hamid looked at policy related the role of analytics in higher education in terms of helping higher education sector address some of the challenges that they're facing, whether it's lack of funding from governments, or whether challenges to do with adoption of new technologies, or dropping in student numbers, and so on and so forth. And Hamid did a PhD. This is Larian Como, and Larian Como is looking at engagement patterns in learning management system, particularly recorded lectures. He's looking at how students actually view those recorded lectures, because this is one of the most hottest debated problem in the world, where students want lecturers to record their lectures so that they can view them, and lecturers mostly are resisting because of the fact that they think that if they record their lectures, students won't come to lectures. So Larian PhD is really looking at if these things are made available, would it be possible to understand how they interact or engage with those? And he looked at over 35 million data points, engagement data points, and it's just preliminary coming up with kind of visualization of that data to see how students engage. As you can see in the diagrams here, the third diagram on your right really tells you the times where students engage and how fast they they look at those recorded lectures in terms of time, and that gives the teacher an idea of how flexible they might provide those recorded lectures, and that students indeed are using them for learning purposes. And then you have Ifeanyi Glory, just completed about a year ago. And Ifeanyi looked at improving the quality of teaching, or teaching analytics. And he did really interesting study whereby because of privacy, for privacy purposes, we could not have access to actual data. So he built some programs that generated synthetic data, and then used that synthetic data to emulate, if you like, teaching evaluation data about teaching quality, and then build some models that help teachers to think about different ways to improve their teaching. And then he validated those models using actual teachers who went and looked at the evaluations, and then the dashboard that was developed, and then provided feedback. And
Ben,
Dr. Matthew is...
Sorry, Ben, if you could round up in the next minute or two.
Sure. Yeah, so the last one here is he's looking at really the application of machine learning models within the healthcare. The idea is that a lot of those models are being used there to make actual health decisions, but then nobody really understands how those models work. So Matthew is just starting out. Yeah, so this is just summary of some of the key issues that we need to think about when we're doing educational research. And we had talked about those in earlier on, but essentially this is just a summary of bringing all this together. And then the last few slides are really some of the critical questions that we need to ask and think about when we want to continue doing research in this area. Some of them has to do with access to learning analytics, who is allowed to access them, who is not allowed to access them, and how they are shared, and things around models that might be biased in the way, or the models might be misunderstood, and then there might be influencing decisions that could be biased and put some people into risk, and issues around transparency as well. Data governance is big in that people might not be interested in sharing their data if there is no institutional data governance framework that clearly states who has access to what data and who and how that data should be used or should be shared. Right, so in general, I think big data in education. It's a really a new area of research. And I think a lot of work that has happened so far really at experimental basis. There are very few universities that have really sustainable support system around the utilization of big data, leave alone big data and analytics. But for most part, I think we still, as education, we've a long way to go in terms of harnessing the actual potentials of big data in education. And perhaps compared to other sectors like health, transportation, telecommunications, those sectors are probably far ahead of education in terms of utilizing the value of big data in education. So with that, I think I'll stop here. Thank you again, and sorry for going beyond beyond time.
Perfectly okay. Thank you, Professor Ben Daniel, for that epic journey in which you capture historically the development of institutional research, and in particular, big data. And with that evolution came increasing complexity, but also increasing utility value. And I suspect that for this audience, there is something of relevance in the various components that you presented. So folks, we have roughly 25 minutes for discussion, open discussion, question and answer, comments, further contributions. And I'll start with Kanyezi Kele. Please go ahead. Can I please request that you are brief in your question or comment? And we'd like to give as many people an opportunity as possible. Please unmute Kanyezi. All right, while Kanyezi finds his or her voice, can I invite other comments, contributions, questions? So perhaps let me then spark the discussion, Ben. What has been, in your experience of the various institutions in which you've worked, what has been the response of management and leadership to this kind of work? Has it been welcome? Has there been resistance? Has there been support for it?
Yeah, so the universities that I have collaborated with and worked with, including this current one that I'm working in, has been fairly, you get a mixture of positive response as well as caution. And I think that's perhaps the best way, because there are a lot of open issues that perhaps we need to be very careful before we actually jump into fully jump into utilizing big data in education. And some of those around privacy and some of those about confidentiality. But what I've learned is that for any of these initiatives to succeed, we need senior management buy-in. You can have a lot of initiatives happening in various departments or units, and if there's no comprehensive, sustainable institutional way forward, it's not gonna go anywhere. So you need at least the champions from above. You need institutional support, and that's certainly some of the research coming out of Hamid, my previous student work, that for higher education institutions to really fully leverage big data, and then senior leadership need to provide the support needed, whether it is technology, whether it is capacity, because it also requires a lot of capacity development, It requires establishing perhaps even a different unit. You need the statisticians and all kinds of qualitative, quantitative researchers or data analysts to come together. You need, of course, if you're dealing with the learning and teaching, you need people of instructional designers and people from educational backgrounds to come and work together as a team in order to tackle some of those approaches. Yeah, so institutional support is key.
Yeah, thanks for that, Daniel. Please, folks, you are welcome and invited to engage Ben in any area that you find you need clarification or to contribute to.
There are questions, Prof, on the chat. Sorry, on the Q&A.
Okay. Will you please read the question?
One from Richard. Is the data warehouse at Otago University locally stored and or in the cloud?
We have both. We bought a system a few years ago. The system is quite cranky because it's a system that kind of captures all kinds of information. So we have that, but we're slowly moving some of our data to the cloud.
Okay. A follow-up question from Richard is, Prof, are you involved in analyzing big data related to research, not just for admin and research?
Yeah, I am, and especially with some of my students, we're looking into that, and we're also experimenting with different tools, and we work closely with ITS and Quality Advancement Unit, which is a unit that responsible for collecting all kinds of data and ensuring quality on all aspects of teaching and learning at the university.
A question from Jacqueline. I would like to hear how the increased use of online teaching and hybrid models impacted on research in this area.
Oh, that's a good question. You know, when COVID-19 happened, a lot of things happened so fast, and I think big data and analytics became quite important immediately to almost everyone. And so it has has impacted it quite a lot, and it has also opened up new ways of thinking. I mean, an example could be, for instance, engagement patterns. Our university bought a system for lecture recording called from Echo 360, but then they branded it Otago Capture. So Otago Capture became available, where lecturers can record the lectures and provide students access to those. So from the access, as I said, one of the students looking at access patterns, we can see the level of engagement and whether students really are engaged in that fully online or blended or hybrid. And we increasingly finding out that the hybrid model of teaching is perhaps one of the poorest model in terms of reception, because part of it is because students are not used to that, but also teachers are not used to that. So hybrid as opposed to blended. It's very, very hard to teach hybrid where you have people on the screen and people in the classroom at the same time. So there are a lot of research questions happening there. People are asking questions. What is the best way to ensure that hybrid teaching is actually made better?
And another question from Tyrene. Have you found this sort of development in big data to be more advanced in a developed country like New Zealand as opposed to developing countries?
No, I think you get a mix. There are a lot of universities in developed countries actually that maybe even never thought of it for all kinds of reasons. And again, big data really initiatives can start as small as small projects. An idea around data science and data science programs. I think a lot of universities, especially in Africa, I started looking into that and having some programs. For instance, is it University of Rwanda University as I think Center for Excellence in Internet of Things. I think they have some pockets of data scientists there that are doing really interesting work. So yeah, so it's not confined to a country. I think certain universities in certain countries have gone far. For instance, Australia is perhaps further than New Zealand, and certainly I think Canada is also gone far because some of those researchers actually come from those countries, or the early researchers, or the people who are the founding people around those research areas. They come from those countries, so their universities have advanced quite a bit. But yeah, as I said, in general, it's a new area for everyone.
Over to you, Prof. Dunbar.
Thank you. So Ben, a follow-up to that comment and question, there might be an impression that big data requires big infrastructure. So what advice would you give to maybe a novice academic who wants to institute an evidence-based approach to teaching and to research?
Yeah. So again, as I said, big data is really a paradigm, a way of thinking. You don't necessarily need a big infrastructure. Of course, the size of the infrastructure can scale depending on where or how far you want to venture. You could start with any legacy system database and just pull that information and do some kind of data mining, if you like, traditional data mining, looking for patterns, and then develop simple models and just look at what insights you can kind of derive from those models. If you wanted to understand everything in terms of what is happening in the institution, and that's where investment in a large scale infrastructure is necessary. So you need to have a centralized data warehouse, for instance, where all your student records are kept, and that all your systems are in a way able to talk to each other. And that way you can easily harvest data and process them and spit out different kinds of reports. So yeah, so you don't necessarily have to have bigger infrastructure to employ data mining techniques or machine learning techniques in order to identify patterns that can help you understand what is happening in the institution. For instance, if you just look at your teaching, you might start that with student evaluation data. If students are having those, if you have an evaluation system in the institution that is sent out to students to evaluate their teachers, and that data comes to a database. And if you wanted to know really, okay, the Department of Chemistry wanted to know what is their quality of teaching, and you probably can run analysis, simple descriptive analysis of the average scores across all the subjects, and then kind of benchmark the departments or the subjects based on that, and provide some useful information to the people responsible in that department that it looks like you're performing below the average. So maybe you need to think about how do you improve your teachers, and that's where a unit like yours would go and put together programs for teachers to learn, whether it's course design, whether it's assessment, and today we know that assessment online is big, all those kind of things. So that's evidence-based. So you can start small and grow from there.
A question from Ganyezi: can big data be accessed in simple technology and at a cheaper cost in developing countries like South Africa, where the majority of students cannot afford data bundles to access lessons?
So the question is, can big data be made available?
Can big data be accessed in simple technology and at a cheaper cost in developing countries?
Yeah, I mean, the whole idea of cloud computing, there's a bit of, I know for sure that Microsoft does provide some provision for universities, especially in developing countries. So there might be a deal that maybe the ITS or the IT department or unit or whoever is responsible for IT to reach out to Microsoft and see what would be the available support that they might provide, and that might be hosting data on the cloud. And I'm not sure about Amazon, because Amazon also has some capacity there, but Amazon might be mainly for commercial purposes. But Microsoft and IBM, I think, have history of collaborating with universities, especially universities that cannot afford to pay for an infrastructure. So there's a possibility. That's one way of doing it.
So Ben, just to reinforce the point you're making, most of our ISPs are zero rate access to institutional data. So once you gain access, you are not charged or not timed for it. So Ben, I want to use this opportunity to reinforce some of the work that you've been doing, which we are also doing. Mm-hmm. So we have several projects on the go, but I'll refer just to two of them. Mm-hmm. The one is our Access and Success project, where we encourage an evidence-based approach to investigating student success. And we make available research grants to enable you to investigate an area of burning interest, of interest to the institution, of interest to your discipline, and more importantly, of interest to yourself. Mm-hmm. And to supplement that, we have what we call the Teaching Innovation and Quality Enhancement Grant, which similarly makes available resources to enable you to conduct inquiry, evidence-based inquiry into these areas. Now, because we are at the end of the year, both those grants are already oversubscribed, but please, we encourage our participants here to look out in the new year for invitations to apply for these grants. We encourage collaborative research, communities of practice. So ideally, the community of practice would be transdisciplinary and involve individuals from different areas, different colleges, different schools, etc. So with that, Ben, let me thank you for an excellent presentation in which you provide a bird's eye view into a complex field, but which can be accessed in simple ways. And I think we often lose sight of the importance of the individual and the individual contribution in the maze of complexity. So all of us can contribute to institutional development by engaging in research in our little private domestic domains, if you like. So Ben, we would like to continue our engagement with you, and hopefully when the horizons open up, we'll extend an invitation for you to come and spend some time with us at UKZN.
Yeah, likewise.
Wonderful. Look forward to an invitation from you. Colleagues at UKZN, thank you very much for joining us. And we hope to see you in our forthcoming invitation, webinar series. And look out for these invitations in the general university notice system. Thank you very much.
Thank you, Prof. Ravi, and thank you, Lucio, and thank you, colleagues. It's been nice meeting all of you, and I hope we'll continue this collaboration. Thank you very much, and have Absolutely. A good day.
Likewise.